Okay, what's going on, guys? Embedded Monk here, and today we're doing day one of my embedded adventure, where I'm as absolute beginner in embedded systems, trying to understand and do cool stuff with ESP32 microcontroller, um, and in previous series, I spent first like 10 to 15 minutes to explain why am I doing this. I'm not gonna spend like more time explaining this. You can check out this video if you want. And today we're gonna continue the project that I started in this series. So if you're interested, you can take a look. So let's get started. In the previous series, we developed this this amazing professional schema. I'm not very good at electronics design, but nevertheless, we decided to make a traffic light. So we will connect three LEDs to these uh, uh, pinouts that correspond to GPIO4, GPIO2, and GPIO15, and connect them to the power line and then to the ground. Also, write some code, some very dumb code actually, but nevertheless, we have the some macros for defining the numbers of LEDs for corresponding traffic lights. Also, some delays, and as far as I know, okay, I was like resetting my PC recently, but let's try and build it. As far as I remember, it has built correctly, even without any errors, so we are very lucky here. But today's task is to assemble the circuit and try to flash this program and see how it works. This is actually the part of a bigger project, because the bigger project is to actually control these three LEDs. So ESP32 will receive request from some HTTP client and do some stuff, like, for example, I will send like a post request to set this LED to on or set its brightness somehow. But firstly, let's make just a traffic light. I guess it's simpler, and then I hope we'll get to how the Wi-Fi is managed on this thing. Okay, so we have built this. Let's now assemble the circuit. I hope this will be okay. Just have a schema in front of me. Okay. By the way, as you can see, I placed the paper here because the table is like have this glass surface and it is very reflective. So probably, I hope it somehow somehow improves the web camera image. Okay, so let's just place the separate LEDs here. I picked the resistors on the 220 ohms. I hope it is enough to not burn out the LEDs. So let me. Okay, by the way, I guess the longer leg is like, okay, let me Google it first. Yeah, as you can see, guys, I'm a total monkey here, so I'm not even know which leg from LED is positive. Okay, so the so the longer leg is positive as far as I understand. Okay, so I'm not a total newbie. Okay, so this one is positive, so I guess should place it like this. Okay, and by the way, if like the breadboard connects only dots that are in the column, so the resistor should go from here to something else, because it won't fit here, as you probably can't really see, but like there are only 4 dots left, and I won't be able to fit the resistor here, so I'm probably gonna like fit it outside, for example here. Yep. And now we are gonna pick some like other LEDs. By the way, I have 20 LEDs, but this one is actually bigger than any of others. They're all basically very small. So yeah, you can take a look. It's very small compared to this one. I guess they just accidentally put this one here, like a surprise. I don't know. Okay. So let us put the yellow one here. Okay. Yeah, in the previous series I said that I will use the knife, but it is kind of broken, so probably scissors are a better option for cutting the resistors off. So let's stick with this option. Okay. And probably the second one as well. By the way, I haven't answered one question in previous series. Well, while I'm assembling, I will answer some questions. Why have I chosen a ESP32 microcontroller and not any of others? Well, I guess I was actually choosing between ESP32, STM32, and probably Raspberry Pi. I wasn't even considering Arduino because I had a bit Arduino lessons in school, and it didn't give me any like understanding of how it works. And actually I forgot a lot of those lessons, as you can see. But why not STM32? STM32, I guess it is, well, too overcomplicated. Well, I heard such an opinion. And Raspberry Pi is more like a computer. Oh shit, okay, here it is. And Raspberry Pi is more like a computer. So Raspberry Pi is a good thing if you want to do something with embedded Linux, as far as I know. So I wanted more to explore the hardware, like low-level stuff. So I wasn't really interested in embedded Linux, but who knows? Maybe this channel will one day have a video with a Raspberry Pi. Okay. So, unfortunately there is not enough space here, but hope you guys can see. This is how I assembled this thing. We have the red one right here, yellow one right here, and there wasn't really enough space here. It was very tight on it, and I decided to place it just in the second row. Well, I guess it should work. Probably there's no actually a difference between this part of breadboard and this part of breadboard, since you just connect in columns. So let's just assume that it should work. Okay, let me check on this. Okay, the longer leg. Okay, the longer leg, correct. Here, the longer leg, correct. Okay. So now I'm gonna cut some jumping wires. Well, I have 2 of them, but I think I need more. Definitely need more. Okay. well, I don't really know how to do it correctly. I just like do it in this way, but I probably can damage them, so I definitely don't recommend to do this my way. Okay. So, firstly, I guess we should connect the... Well, let's take a look at the schema. So, firstly, we should connect the D4 to... By the way, I haven't like signed which is what. Okay, let's assume this one is red. This one is yellow. And this one is green. Okay, perfect. So let's connect red to D4. Okay, let's switch to the table. Okay, D4. Oh, by the way, ESP32 is placed wrongly, in a wrong way. So let's just switch it a bit. Okay, seems reliable. Trust me, I'm an engineer. Okay, D4. Oh man. 3 G and D, D15, D2, D4. Okay. Let's go. Okay, next we should connect the D2 to the yellow one. D2, 3 G and D, D15, D2. You know, it's very funny how I placed them in this way, and they are like actually placed in the opposite way. So I actually meant that D15 will be the red one. But actually, you know, this is quite logical because you place the closest to the LED, so you don't have to. Well, I'm not gonna lie. This, like, there will be a mess with these wires, especially in the bigger projects, I guess. Okay, in the D15 to the green one. Okay, so I'm kind of finished, almost. Only the ground left. So the D4 goes to red one, D2 goes to yellow one, and D15 goes to the green one. Yeah, you can see. I hope you can see. Damn, definitely should buy a new web camera. Okay, so now, as we planned, we're gonna connect the their negative leg of the LED to the power line, and then to the ground. So let's do that. Okay. By the way, I guess I should ask ChatGPT why do we place resistor in front of LED, because sometimes we should do that, sometimes we shouldn't do that, and I'm not really sure how to answer it. Probably this is the dumbest and simplest question in electronics, but I haven't got the certain answer here. Because some of these, as far as I know, they have like either resistance or something like that. Oh my goodness. This one is definitely damaged, as you can see. Totally unreliable jumpers, but okay. It's better than nothing. Okay, let's try it one more time. Okay, this one seems unbroken. Probably it's better to have both like long jumpers and short jumpers, because as you can see, there will be a mess here. Because I can act like almost two separate rows with this with wire that is like almost like 15 centimeters long. Okay. By the way, guys, I hope you'll write some comments here, but like, you know, when I do some assembling or something else, I would like really enjoy to answer your questions. So I can, because this is really just a very slow process, and I guess I should I don't know, like, let me know in the comments whether you like or not when I will talk on some different topics not related to embedded, like programming or like hardware, etc. Okay, so we connected this one. We connected these LEDs, these here, and the only thing that it remains is to connect the damn. Look at this. Another one. Another broken wire. But probably we can't use it with some. We should be careful, of course. Well, you know, let's try. Let's try, or we'll be fry. Okay, let's connect it to the GND pin. Okay, so as you can see, it's just, I remind you guys, it's just a traffic light. So it's just a basic circuit that should blink 3 LEDs, and it looks very scary, as you can see. But I connected everything right. So as you can see, for example, here, the this wire, yep, it goes here, here, here. It goes from D15 all the way to the resistor. Then it goes through the resistor, it goes to the LED, and then it goes here, and it goes to the power line, to the negative power line. Yep. So, seems promising. I hope nothing will be broken. Okay, so it goes to the ground. It goes to the ground. And this one goes to the ground as well. Okay. So, but firstly, I will disconnect the ESP32 and flash the code there. and take the, I don't know, man, maybe I'm like very dumb here, but I usually put this in isolation. So like this. This is just actually a package of ESP32. So let's flash the code. By the way, I can't flash it actually. I have like two USB ports. One USB port is connected to the microphone, and the other one is connected to the web camera, so I just have to turn something off. But okay, I will turn off the table cam, I guess. I will just edit. I hope you get, oh, okay. So let's connect it. Then I have my USB hub also. Very expensive. So connected it. Let's open the Visual Studio and let's just flash it. As far as I remember, the port was the COM5. Let's flash. Okay, so the flash was successful. As you, oh, you can't actually see, but by the way, I don't know how I will actually show you show you this thing. You can actually take a look here. So the red one is the GPIO2, and it should blink here for actually it should have blinked for 5 seconds, but it doesn't seem like 5 seconds. Oh no, it's actually yellow. It's actually yellow. Yellow is the GPIO2, and yellow time is 2 seconds. So probably it does look like 2 seconds. So seems reliable. Okay, so let's switch back to the table. Okay. By the way, I probably can power it from some other device. I definitely can power it from some, I don't know, from other computer, something like that. Or you will just hear me very badly, which I don't want to. Okay, so let's, yeah, I will add just the camera here. Yep, perfect. So, let's okay, so I'm gonna probably pause it right here. Yeah, probably gonna pause it right here, because otherwise I have to, you know. Okay, you know, let's just. I hope you guys can hear me well. Probably the quality of the sound is actually very bad, but now I'm able to connect the ESP32 here and power it on. Okay, one moment. Let's just assume that it's perfectly aligned. Yep, one more check. Free GND. Yep. This one is D15. This one is D2, D4. then there goes here, here. Okay, so okay guys, let's hope that we won't burn this out. So let's just connect it. Okay, so 1, 2, 3. Okay, so the red is blinking, then the yellow is blinking, then green. Okay, we are done. We're done here. I hope you can see this. It's actually beautiful. Well, let me turn off the light here. So as you can see, red, yep, red, yellow, green. Here we go. Red, 5 seconds. And then yellow, then green. Perfect. So we're done. We're done here. It works. So congrats. Now I get okay. It looks so jolly. So I just can't stop just to stare at this traffic light. Okay. So now the task is to actually try to control these LEDs with Wi-Fi. So the circuit is ready. We don't have to assemble anything. We just have to code, and I'm probably gonna power it off right now. Damn, so beautiful. By the way, the new year is coming, so I guess to build something like that for a Christmas tree will be quite cool. To like to connect these LEDs so they will blink in some different ways, maybe different modes. So, for example, with the Let's See controller that I showed you in the previous series, we can actually modify the brightness of LEDs. So we can set them. This one, for example, with the 10-bit resolution, it will give us like 1/4. No, even less than 1/4 of the brightness of LED. So you can modify it here. By the way, you can find this code on my GitHub, like if you want. I just uploaded yesterday's traffic light code here, but the LED blink is still here. You can check this out if you want. So, link in the description, you know. Okay, so let us turn off this thing and continue. Okay, turning this off. Sorry, bro. Sorry. Okay. One moment. Well, I hope you guys can hear me well. Yep. Okay. So, let us continue. So now the task is to actually somehow control this thing. To somehow control this thing using Wi-Fi, and well, probably I'm gonna read some theory now because I have some materials here. The Random Nerd tutorial, by the way, a good site. I hope there will be some materials on Wi-Fi, so let's check them. Yeah, ESP32 Wi-Fi. Okay. You know, we can actually use ChatGPT, but one ESP3. Yeah, that's actually what I want to do. To just, well, guess there is no difference if we communicate between two different ESP32s and between ESP32 and some client device. So probably, probably, okay, parts required, Redboard install libraries. Okay, let's just Google this. ESP32 Wi-Fi. Yeah, I just want to check the official documentation here. No, that's not what I wanted. ESP32 IDF Wi-Fi. Let's check this one. One moment, guys. I just checking that docs to a little bit to get a little bit of understanding. Which allows Wi-Fi allocate resource. Wi-Fi transition control structure. Okay, so we with this function we'll allocate some kind of like not a socket, but rather the just a structure that can store some Wi-Fi configs. Okay. By the way, let me check. See if OS functions. Seems like a lot of things we can specify here. Stack configuration parameters opposed to ESP Wi-Fi. Okay. Okay, guys, you know what? I guess I should actually spend some time to play around with these functions and probably get back to you when I know when I actually know something from it. But I will continue recording. But if you leave, I completely understand you. If you haven't left already, so let's just pretend that I just want to dive into these functions and to understand how they work. So, and maybe to write some theory notes that I usually write. But I understand that we have to allocate some structure. The structure with these fields is a configuration structure. Then, well, okay, of course we can delete it. Alright, is B Wi-Fi set mode. What is Wi-Fi mode? CAP. Wi-Fi start, Wi-Fi stop, restore. Well, okay guys, so I guess we should finish here. I should dive into this thing firstly, and then we'll do some cool experiments probably in the next series tomorrow. By the way, I hope I will load some theory materials on this topic by tomorrow, so you can also check them, and well, I just distribute them freely here on my Google Drive, so I will leave a link in the description. By the way, all the links in the description, like for the theory materials, for the GitHub repo that I'm working on here. So I hope you guys enjoyed this video. If you enjoyed, like, hit the like, write some comments. Any questions are I will be enjoy to answer them. It will be a pleasure. And subscribe, I don't know, watch. So bye everyone. See you tomorrow.